For number 1, I chose this design of the chair because it is the most appropriate and practical design for a chair. It ensures that the center of gravity of the weight above the chair is in line with the support below the chair. It also ensures the longevity of the chair because there is only compression force acting upon the support of the chair, unlike the other design where there are tension, compression, and bending forces that act upon the support. For number 2, this design is better because with the bridge having more contact area with the link ensures that the force is properly transmitted to the succeeding components. It also allows the link to move with respect to a sprocket, unlike the straight bridge like the other design. The rounded edge design is more practical and safe than the straight edge design. First, it is practical because it is much easier to achieve the rounded edge design by simply bending the pipe to the desired angle, unlike the straight edge design where the pipe is needed to be cut and then welded back together to achieve a turn. Second, it is safer because any collision with the rounded edge design can guarantee an injury-free but maybe not bruise-free. Unlike the straight edge where the pointed edge can cut through or pierce through the material or object colliding with it. And for number 4, I chose this design because this is the industry standard for flange covers. It also ensures the airtightness of the vessel and its hold to each other. If ever the vessel gaps became too loose, the maintenance will be easier as tightening the bolts and nuts is all it needs. Modularity is also better because if ever the components of tightening wore out, it is easy to replace without doing much to the vessel itself. The concave outward design is better than the convex design because it can hold a greater volume and any risk can be minimized. The design can hold greater volume of fluid because of its outward concave design, thus lessening the amount of manufacturing for similar vessels and the financial burden for a company. The safety risk is minimized because in the event that the vessel cannot contain the pressure and the fluid escapes to the ends of the pressure vessel, it will burst out. The concave design has more travel distance with respect to the end of the pressure vessel, thus generating more force. And compared to the concave design, where it can ablate or reflect back some of the force, the fluid is acting upon the pressure vessel, thus lessening the force when it bursts out. This design is more practical because of its nozzle placement and accessibility. The nozzle placement is better because liquids tend to gather at the bottom of the dispenser, and it is easier to finish up the liquid soap, practically in this example, inside than using a pump and a pipe. The accessibility refers to the ease of access of someone washing their hands. As the nozzle is already low, there is no significant effort to reach out for the nozzle, to reach out for the dispenser. Also, the pushing mechanism or the button is better as the button is wider and this makes it easier to use.